Good morning, I am Ashok. So in this video, we are going to cover the topic ratio and proportions. We are going to divide this video into two parts, like where you can see in the status bar the chapters. In the first one, we are going to cover the definitions of ratio and proportions. In the second one, we are going to solve different kind of problems. And one more thing I would like to tell you is, in order to create the shortcuts in the later on topics, we need ratio and proportions. So please learn very carefully. Let's get started. Now, what is meant by ratio? So before that, why the ratios are needed? See, in the real life, we need comparison. Let us take I'm 40 years old and you are 20 years old. I'm like double the age of you. And let us take my weight is 80 kgs and your weight is 40 kgs. Okay, so I'm double the weight of your weight. So it's like you are using mainly it for comparison. Not only that, let us take you are designing some automobile like car and all. So you are not going to make it in the original model. So first we are going to use them for scaling. Like we are going to make prototypes. Then we are going to make the original model. So even for scaling also, ratio and proportions is very important. Now, what is ratio? We already know. Ratio is nothing but comparison of two quantities, which I given you just now. And we are going to write the ratios in two forms. It can write as A is to B, or you can write this as A by B. Both of exactly the same. Now, what is meant by compounding ratio? Think it of like a multiplication of two ratios. Let us take I'm having one ratio A by B. I'm having one more ratio C by D. So if you multiply both of them, you are going to get AC by BD. That's what you are going to call it as compounding ratio. It is like combining or multiplying two or more ratios. So what is continued ratio? Continued ratio is like combining two, three ratios together. Now there are different ways of combining it. I will tell you one by one. But remember, this is very important when you are solving the problems. So there you are not going to have only one ratio. You are going to have two, three ratios and you are going to combine all of them. I will tell you one by one method. Let's go with the first one. Let us take you are having A is to B as, you are having A is to B as 1 is to 2, just for simplification. And B is to C as 2 is to 3. So this is the first kind of continued ratio we are going to discuss about. So here, if you observe, the common variable is B. Whenever the common variable is exactly the same, you no need to do anything. You can just write them together. Like if you want to find out A is to B is to C, you can directly write 1 is to 2 is to 3. That is as simple as that. But make sure you are having same value in place of the common variable. Second one, let us take A is to B equal to 1 is to 2, but B is to C is 6 is to 7. As you can see, our common variable is B, but we are not having the same value for B there. So the second one is multiplying or dividing the ratio is not going to change or affect the relation between the ratios. Like you can multiply with the common number, you can divide with the common number. It is not going to change the value of ratio. That is 1 is to 2 is same as 2 is to 4 because second number is double of the first number. We're comparing the same thing. That's why multiplying or dividing the ratio with the same number is not going to affect its value. Now here, we can't, no, we can't directly convert 6 into 2. There we have to divide. That will become difficult. But by multiplying with 3, you can make 2 into 6. So just multiply it because I know multiplication is not going to affect the ratio. But remember, when you are multiplying, you should not disturb the relation. That means when you are multiplying one variable, you have to multiply each and every variable in that ratio. For example, if I want to make sure B as 6, I'm going to multiply with 3, but I should not only multiply 2, I have to multiply this one also. So now our A is to B is 3 is to 6 and B is to C is 6 is to 7. Now as the common variables are same, you can directly write A is to B is to C as 3 is to 6 is to 7. That is. Now the third one. Sometimes what happen here is even though after now combining them, or there is a chance that you can't get the other variable by multiplying with some other number. Like I will give you one example. Let us take like this. A is to B equal to 1 is to 3 and B is to C equal to 5 is to 7. Now as you can see here, I can't multiply 3 with any number to get 5. Similarly, I can't multiply 5 with any number to get 3. So in those kind of scenarios, what you can do is make sure both of them are equal to their LCM. That's it. So what is the LCM of 3 and 5? 15. So make sure that B value in both the ratios is equals to 15. So how you can make it 15? Multiply with 5. How you can make it 15? Multiply with 3. That's it. Now our A is to B is 5 is to 15 and B is to C is 15 is to 21. As the common variable is same, you can say A is to B is to C equal to 5 is to 15 is to 21. That's it. First one. If the common variable is same, just combine as it is. Second one. If you can get the other number by multiplying with any number, do it and make sure you are having the common variable. If you can't multiply and get the value, make sure both of them are equal to their LCM. In these three ways, you can combine two or more ratios. That's what you are going to call it as continued ratio. Now, I hope this is clear. Let's move on to the next one. What is meant by simplest form of ratio? Simplest form is nothing but you can't further reduce the ratio. For example, let us take you are having 20 is to 40. You can write it as, if you cancel the second table, 10 is to 20. If you can cancel the second table, again you are going to get 5 is to 10. If you can cancel the fifth table, you are going to get 1 is to 2. See, all of them are actually the same. But the simplest form is this one. You can't further reduce the ratio. So in definition, what you are going to say is simply cancel the HCF. Because, see here, what is the HCF of 20 and 40? 20. Just cancel the 20 table. You are directly going to get the simplest form of the ratio. So if you cancel the HCF of the terms, then whatever the ratio you are going to get, we are going to call it as simplest form of ratio. Or simply saying, whatever the ratio which you can't further simplify, we are going to call it as simplest form of ratio. I hope these two are clear. Let's move on to the next one. Now coming to proportions. So proportions is like equality of ratios. Let us take that A is to B equal to B is to C. Then we are going to say it as A and B, sorry, both the ratios are in proportion like this. If A is to B is equals to B is to C, or A is to B equal to C is to D, then we are going to call them as in proportion. Proportion is nothing but equality of ratios. Now let's go the different terms one by one. So here, the first one is mean proportion. Let us think like this. You are having A is to be like 9 is to 25. Then the mean proportion is nothing but root over of AB, like root over of 9 into 25. Like that, you are going to get 50. Okay, I hope this one is clear. Like 225, that's it, gonna be 15. So mean proportion is root of AB, or I will write it here directly here. I hope that is clear. Mean proportion is when you are having a ratio A is to B, root AB, we are going to call it as mean proportion. Now remember, in continued proportion, you are going to have only three variables like A by B is equal to B by C. Then we can say that B square equal to AC. So this is what we are going to call it as continued proportion. Like one common variable is going to be there. Or I can also say A by B is equal to B by C is equal to C by D. See here, one variable is getting continued or not. So in continued proportion, you are going to have at least one common variable between the next ratio and the previous ratio. That is what meant by continued proportion. Now, next, sometimes you will see in the examination to ask you to find out what is first proportion, what is second proportion, what is third proportion, these kind of things. So let us take that A by B is equal to C by D. In that, A is called first proportion, B is called the second proportion, and D is called the fourth proportion. For example, if you want to find out the first proportion, A, you can write equal to BC by D. Like whichever he is asking, you just need to find out the term. So A is called the first proportion, B is called the second proportion, sorry, this D is called the fourth proportion. But be careful with third proportion. In third proportion, you are not going to have four variables, you are going to have only three. Like A by B equal to B by C. In this case, okay, this particular B, okay, sorry, A, B, C, third value C. This C is called the third proportion. For example, I can write B square equal to AC. If I want C, it's going to be B square by A. So the terms are going to be there. First value, first proportion, second value, second proportion, third value, third proportion, and fourth value, fourth proportion. That's it. But for 1, 2, and 4, you are going to have four variables. For third proportion, you are going to have only three variables. Okay, let's move on to the next one. Now, you all know these properties. I'm going to just write it here again. See, properties we are going to use only to simplify the ratios, nothing more. For example, A by B is equal to C by D. The same thing which we are doing here. Okay. Now, what is meant by inverted property? Just invert them. If A by B equal to C by D, B by A will be also equal to D by C. This is called inverted property. Okay. Then again, take the same ratio. A by B equal to C by D. Then altered means cross them. A by C is equal to B by D. This is called altered property. Okay. Now, what is meant by componendo and dividendo property? See, simple thing. Take the same ratio. A by B equal to C by D. Componendo means add them, like add the denominator here. So, if A by B equal to C by D, then A plus B by B is also equal to C plus D by D. In componendo property, we are going to add the denominator. Similarly, what is dividendo? If A by B is equal to C by D, A minus B by B is equal to C minus D by D. That is called dividend property. I will take the values and explain also, don't worry. Similarly, what is component and dividend? It's a combination of both the properties. One time add the numerator, add it to the numerator, one time subtract from the numerator. If A by B equal to C by D, then if this is true, A plus B by A minus B will be also equal to C plus D by C minus D. Let us take an example and check whether it is true or not in all these values. Okay, let's go. So what I'm going to do is, I'm going to take that. Yeah, 2 by 4 is equal to 1 by 2. Both of them are exactly same. So A by B equal to C by D. That's completely fine. No issue at all. You can take any number. That's going to simplify all. You're going to satisfy all the rules. Now let's go for inverted ratio. Just reverse them. 4 by 2 is equal to 2 by 1. Yes. Because, B by A equal to D by C. That's the meaning of inverted property. Now let's go for altered property. I will write here. It will be easy. So A by C equal to B by D. See here. We're going to reverse them. So 2 by 1 is equal to 4 by 2. Yes, that is also satisfying. Now let's go for component property. So 2 plus 4 by 4 is equal to 1 plus 2 by 2. A plus B by B equal to C plus D by D. Then what will happen? In this side you are going to get 6 by 4. It will be 3 by 2. This is exactly the same. Now dividend property. You can try once again. So 2 minus 4 by 4 is equal to 1 minus 2 by 2. The same thing you are getting. Last and final one. Combination of componendo and dividendo. So A plus B by A minus B is equal to C plus D by C minus D. See here. 6 by minus 2 you are going to get. Here 3 by minus 1, which is exactly minus 3 on both sides. So these are the properties of ratio and proportions, which is not going to disturb your ratio, but it will be helpful to you to simplify them. So these are the main properties of ratios. Okay. Now, with this, we are done with the definitions and the first chapter. Now we are moving on to the second chapter in ratio and proportions, where we are going to solve some of the problems. So in the video, I am going to make it into two chapters. If you already know them, just directly dive into the second part. Okay, let's go. Now, this is very important. This is where people are going to do mistake. I forgot to give you the values. See here. Let us take that A is to B equal to 1 is to 2. Then try to find out this value. Assume that A is to B equal to 1 is to 2. Then try to find out the value of 5A plus 3B by A square plus 2B. What people will do is, just because I said A is to B equal to 1 is to 2, they are going to take A equal to 1 and B equal to 2, and they will try to simplify this one. That is very wrong. Why? I will tell you. So before moving on, I will take one more example. Now I want you to tell me the answers of both of them. So what people will do is, they will do like this. And they will say that, see here, 5 plus 6, 11 by 5. They will say answer for this one as 11 by 5, which is right. But here you are also going to get 11 by 5, which is wrong. I will tell you why. See what they will do. They will do like this. And again they will say that it is also 11 by 5. And they will say A equal to 1, so it doesn't matter. No, that is wrong. I never said A value is 1. I'm saying that A is to B equal to 1 is to 2. It doesn't mean that A value is 1 and B value is 2. So ratio is the simplest form of comparison. After cancelling the terms, you are going to get that one, right? Then how you can take A value equal to 1? Why? Because, see here, as long as the ratio of A is to B equal to 1 is to 2, like you can take the numbers 1 and 2, or 2 and 4, or you can take 100 and 200. In all these cases, you are going to get the same answer here. If you want, you can check. But if you change the values here, you are not going to get the same number. That's why if I ask this one, the answer is 11 is to 5. But for this one, the answer is cannot be determined. Why? Let us check that one. See, A is to B, 1 is to 2. That means that there are some original numbers. Let us take 10, 20. We are going to cancel the HCF here, which is 10. You are going to get 1 is to 2. But listen, if you want to get the original number, you have to multiply your ratio with the HCF. Then only you are going to get your original number. Like that, let us take that our ratio is 1 is to 2, and let us take we are cancelling the HCF x. So the numbers are going to be, so how to get the numbers from the ratio? Multiply the numbers with HCF. So let us take x and 2x and solve the problem. Let us take the first one. So what is actually happening here? 5 into x plus 3 into 2x by x plus 2x. If you think properly here, this is 2b, so I will take 2 into 2x. If you think properly here, 5x plus 6x, 11x by 5x, xx will get cancelled, so 11 by 5. So it doesn't matter, you're always going to get 11 by 5. Why? Because whatever the HCF you are cancelling there, if you are not cancelling in the ratio, that will get cancelled in the last step. So you are always going to get the value as 11 is to 5. But see our problem here. So what's going to happen here is 5 into x, fine, 3 into 2x by x square plus 2 into 2x. Here what will happen here is you are going to get 11 in the numerator, that's fine. But in the denominator, if you take x common, x plus 4, at max you can cancel this one. But do you know the value of x? That is the HCF of the original numbers. We don't know. Why? Because we don't have the original numbers. We're just having the ratio. So if the original numbers are 10 and 20, the HCF is going to be 10. If the original numbers are 5 and 10, the HCF is going to be 5. So until and unless you know the original numbers are their HCF, that means the table which you are cancelling, you can never find out the answer for the above problem. That's why, remember, you can only simplify the ratios if the powers are same, like 1, 1, 1, 1. If all of them are ones or all of them are twos, you can simplify them. But if the power of numerator is not equals to the powers of denominator, then the answer is always equals to, cannot be determined. Okay, or can't be determined. Remember, you can only simplify the ratios when the power of numerator is equals to power of the denominator. Otherwise, you no need to solve the problem. You can directly write it as cannot be determined. I hope that is clear. Let's move on to the next one. Now, how to simplify them? A by B, B by C, C by 4. So remember, we want to find out the values of A, B, C by A. So let's find out the first A, B, C values. How you are going to find out? See, I am going to assume all of them are equal to some k. So what you can do here, see, you can take any number of your choice. It's not going to affect your value. Anyway, because I'm going to cancel them, that's why I'm taking k. So then I can write a equal to 2k, b equal to 3k, c equal to 4k. Now I want a plus b plus c, 2k plus 3k plus 4k. So 5 plus 4, 9k. And a equal to 2k. So the answer is going to be simply 9 by 2. So remember, whenever you are having this p by q form, always assume all of them are equal to some constant k and simplify them. That is as simple as that. If you don't want to take k, you can take any number also, like 2, 4, 6. It's everything is fine. It will give you the same answer. Let's move on. Second one, what if it's something into p into q? Then what you are going to do? So when you are having in the form of p into q, like 2a equal to 3b equal to 4c, then what you can do is assume that all of them are equal to their LCM. In our case, what are the LCM of 2, 3, and 4? 12. Assume that all of them are equal to 12 and find out the value of a, b, c separately. So 2a equal to 12, then a equal to 6, 3b equal to 12, then b equal to 4, 4c equal to 12, then c equal to 3. That's it. Then find out a plus b is 10 and c is 3. Answer is 10 by 3. That is as simple as that. If it is p by q equal to some constant. If it is p into q equal to that LCM. I hope that's clear. Let's move on. Now, most of the people are going to do mistake in this problem. The reason here is they will only multiply the numbers. Like if I say, see, the numbers are in the ratio of 3 is to 4 is to 5. And their product, what they're going to do is they're going to only take 3 into 4 into 5 and they will equate this value as 60,000, which is wrong. Why? Because if the ratio is 3 is to 4 is to 5, okay, there is going to be one more variable because the original numbers are not 3, 4, 5. The original numbers are 3x, 4x, because we have to multiply with the HCF to get the original numbers. These are the original numbers. And this is the product in our case, like 3 into 4 into 5. The product of three numbers is 3x into 4x into 5x. But in the original problem, this value is equals to 60,000. So our problem multiplication is 3 into 4, 12, 12 into 5, 60x. 60x cube, because x we are having 3 times. This value is given as 60,000. That means that x cube is equals to 1000 and x equal to 10. So now we want the original numbers. What are the original numbers? 3x, 4x. 4x means 4 into 10. 5x means 50. These are the original numbers. So whenever you are multiplying the ratios, make sure you are multiplying that HCF variable also, like x. That's why when you are getting confused or if you're not getting the answer, make sure that instead of taking the original numbers, always add an x and take it. Like instead of taking 3, take 3x. That's going to give you exact meaning and values of the ratios. Okay, let's go. To 11. So up here to successful is 13 is to 11. And the number of successful students, you need to find that value. So successful is equal to how much? If these many students appeared in the exam, that means 13. So our problem 13 appeared is equal to original problems 14014. Then our problem successful is equal to how much in the original problem? 11 into 14014 by 13. This will give you 11858. That is the meaning of the problem. See what is given, what is the original problem. What you need to find out, what in the original problem. Just do the cross multiplication. You will get your values. Okay, let's move on. Now listen, these are very important even if you are solving the problems of partnership. So first learn how to divide the money. For example, let us take I'm having 6,000. I want to divide this in the ratio of 1 is to 2 is to 3. How you are going to divide? See, I am giving the money to 3 persons. What if I take back the money from them? Again, I have to get the same value, right? That's why add your ratio numbers. So in my problem, 1 plus 2 plus 3, 1, that is 6. So our problem 6 unit, that is actually 6x. I don't want to involve x, that's why I'm taking 6. So in my problem, that is 6. 1 plus 2 plus 3. But in the original problem, that is 6,000. That means my problem 1, that means my ratio 1 is equal to original problem how much? First find out 1 unit value. So once you got this 1 unit value, that's actually the x value, because generally we're going to find out 6x is equal to 6,000, then x is equal to 1,000. That's the meaning of 1 unit. Once you got 1 unit, then find out 1x, 2x, 3x. That is 1 unit value, 2 units value, and 3 units value. Okay, that means first person we have to give 1 unit, that is 1,000. For the second person, we have to give 2 units, that is 2x, that is 2,000. Third person, 3 units, that is 3,000, or 3x, that is 3,000. So in all my problems, what I'm going to do is I am going to add the numbers 1 plus 2 plus 3. That means that we're actually taking 6 units or 6x value. Then find out 1 unit value or 1x value. Then you can multiply with x or you can multiply with 1 unit to get the original numbers. I know the wording is kind of confusing. Just listen it one more time. You will get it. Okay. So what we need to find out, add all the numbers and find out 1 unit value. Once you got 1 unit value, find out 1 unit, 2 unit and 3 units value. Like 3 units means 3 into 1 unit, like that. Let's go. So a sum of money divided among A, B, C and D. So we're having A, B, C and D in the ratio 1, 2, 3, 4. If the share of D is 1800 more than A, see, here D share is 4 and A share is 1. In our ratio, it is more by 3 units. So our problem 3 units more is equal to original problem 1800. Okay. Then what will be the total amount of money with B and C together? So B and C together we are having 5 units C. If 3 units is 1800, 5 units value is equal to how much? 5 into 1800 by 3, which is 3000. That's it. I hope this is clear. Find out and compare what you are having and what you are having in the original problem. Whatever the terms you want, just do the cross multiplication to get the values. Okay, let's move on to the next problem. Yeah. So think like this. 1 year ago, the ratio of Ramu and Somu was 6 is to 7. So this is Ramu's age and Somu's age 1 year back. Guys, remember you have to go back in time by 1 year. For example, take the ages as 6x and 7x. That is when, that is 1 year back. Okay, now 4 years after, hence 4 years means 4 years after. That means this is 1 year back and 4 years after. Okay, the ratio of Ramu and Somu is going to be 7x is to 8x, or you can take 7y into 8y because we're all taking the variable x. So let us see. See here, this is -1, okay, and this is +4. So how much gap is there actually? 5 years gap is there. So for the fast ratio, if we add 5 years, you are going to get present ratio. Like for example, let us take that 5 years back. The ratio says 6x and 7x. So Ramu and Somu, the ratio is 6x and 7x. That is 5 years back. Now, if I add 5 years to it, both of them are going to age. I am going to get the present ratio as 7 is to y. I don't want to take the variable because anyway we can cancel them. Okay, so let's simplify it. Remember, 1 year back and 4 years after. So there is a gap of 5 years. So 1 year back ratio 6x and 7x. If you go 5 years after, plus 5 plus 5, you are going to get the ratio as 7 is to 8. That's what was given there. So now let's do the cross multiplication. We can find the value of x directly. Now, how much we are going to get? 48x plus 40 equal to 49x plus 35. So x equal to directly 5. Now listen, what we want to find out, how old is Somu at present? So see here, this is the person's homo. 7x means 7 into 5, 35. But 35 is 1 year's back age. Now I want present age. So he is going to be 36 years old. So 1 year's back plus 4 future. Once we got the x value, which is the ratio belongs to 1 year back. Now we want like present one. So add one more because we want plus 1 year. 36. I hope that is clear. Let's move on to the next one. So the sum of three numbers is 98. Okay. Let's take that a plus b plus c equal to 98. And the ratio of first to second number. First to second means a is to b equal to 2 is to 3. And the second to third number, b is to c is 5 is to 8. Then the second number, b is equal to how much? Now, here b value is 3. Here b value is 5. Make sure both of them are equal. So what I'm going to do is I'm going to multiply this ratio with 5 and this ratio with 3. Then what will happen? A is to B is going to be 10 is to 15 and B is to C is going to be 15 is to 24. So A is to B is to C equal to 10 is to 15 is to 24. Right. Now I have A plus B plus C here. So here 15 plus 24, 39 plus 10, 49. So my problem 49 sum is equal to original problem 98. If you want, take 49x and find out x value. I am taking 49 units. So my problem 49 units equal to original problem 98. That means my problem 1 unit is equal to original problems 2. Okay. Now what I want to find out? I want to find out second number, which is equal to 15 units. So 15 units value is equal to 15 into 2. That is equal to 30. That's the value of a second number. I hope these are clear. Now guys, if you're having any doubt, please let me know in the comments. Okay. So that's it for today's video. Thank you for joining. We'll meet again in the next session of partnership. If you're having any doubts till now, please write in the comments. I will try to reply as fast as I can. Thank you. Have a good day.